All right, welcome everyone. Today we have a wonderful guest,
Sashko.
Sashko. Wow, sorry, Sashko. He's going to talk to us about GraphQL. But by way of introduction, before I hand it over to Sashko, as you all have heard, our long-term architecture plan put together by Nick. As part of that, we're moving 100% of our client access to GraphQL here at Coursera over the next 12 to 18 months. As part of that, the infrastructure team, Brian and I, and others, we got our first GraphQL schema and endpoint working. You may have seen in your email that we sent out just a few minutes ago. Hopefully you tried it out, give you a little bit of context for what we're going to be talking about today. Anyway, with no further ado, I'm going to turn it over to Sashko, who is on the Meteor team at Apollo. The Apollo team at Meteor, and they're working on some really great GraphQL implementations and are very plugged into the community, and they're going to be a great resource for us as we go forward. So with that, please welcome Sashko.
Cool, yeah, this is kind of like a party for your new GraphQL API that just launched like last hour. That's really awesome. So if I were to introduce the Apollo team, I would say the thing we're most proud about, or I'm most proud about, is our blog. So we have probably the most active blog about GraphQL stuff that you can find out there. You can go there to learn about new developments in GraphQL in general, as well as also new developments in Apollo technology that we're building on GraphQL. So if you want to learn more about what we're doing at Apollo, you can go to our Medium. Not all of you may have used GraphQL yet, especially because it just got implemented. So first I'll do just a really short couple-minute introduction to GraphQL, what it is even. And the best way to do that is, as of recently, the GraphQL.org website. So it got redesigned last week to correspond with GitHub's launch of their new public GraphQL API. Now it's probably one of the better open source technology websites out there, I would say, as you'll see with these super sweet diagrams that our friend Lee Byron made at Facebook. So GraphQL is basically, it's a query language for APIs. So you guys might have heard of REST APIs. REST APIs are basically an HTTP API that you call via certain patterns of URLs. You might pass it certain types of parameters, and you kind of know to expect what you're going to get back, right? You might have an endpoint to get one object. You might have an endpoint to get multiple objects. You might get some other data in there as well. GraphQL is a way of expanding on that concept and standardizing it a little bit so that you know better ahead of time what data you're going to get back from your API, and you get better documentation and stuff like that. So you can see a really simple example just directly at the top of the homepage. If you do a query that looks like this, that has a field project and then a nested field tagline in there, you know for sure you're going to get back a JSON object that's going to have those fields in there nested in exactly the same way. So that's really the core part of GraphQL, is you send it a query that has some nested fields and possibly some arguments, and you get back a JSON object with exactly the same fields. And going over just a few of the top level benefits, this is the one we just mentioned, that you get exactly what you expect based on the fields you typed in. Another thing is you can easily query nested data. So in situations where with REST APIs you would often need to make multiple requests to get the data you want, in GraphQL you can often do it in just one request depending on how your API is designed. GraphQL also comes with a type system, so you can have a complete description of what data is accessible through your API. And every GraphQL server, if it's spec compliant, is required to have a schema definition. So you can look at that and know exactly what data is accessible without having to write an extra layer of API documentation on top of that, like you would have to do with a lot of API systems before it. And the thing that we're going to focus on today are the awesome developer tools you can build with GraphQL that'll make your client-side development experience way, way better than anything else I've ever seen, pretty much. So let's jump into that. And I'll try to escape from behind the podium with the help of this button clicker. You'd think they would preload this stuff. There you go. Maybe they're not using GraphQL. Yeah, so the title is Why UI Developers Should Love GraphQL. And I think after you see all the stuff that I'm going to tell you about, you're going to want to have GraphQL in your API, and you're going to be really happy that you do have that as of today. So GraphQL is a pretty special place in the stack compared to a lot of other technologies, right? A lot of really trendy things these days Like for example, React is something that you only use on the front end. It's something that front end developers can enjoy in the back end, people don't really care about. Or maybe you have a new database like RethinkDB, and often it's something that is more for back end developers, but not for the front end. GraphQL, like only a smaller set of technologies, lives right in the middle. So it's something that has to serve both sides. Both the back end developers have to be excited to create a GraphQL API, and the UI developers have to be excited to consume it. And I think people often think about it as a server-side technology because an API is a server-side thing, right? The back-end developers will often write these APIs and stuff like that. So that's why GraphQL gives people, I think this font might be bigger, but it's okay. Basically, for back-end devs, it gives a lot of benefits. It lets you organize your API really nicely with the strong types. It lets you maybe respond to queries more efficiently because you know exactly what fields people are asking for, right? Like for example, when GitHub was introducing their GraphQL API, they were talking about how they couldn't deal with these REST API requests they were getting because each API request would return like, I don't know, hundreds of fields. And probably a lot of people who are using that REST API are only using like 2 of the fields in that response. And so GitHub was wasting all this time generating these huge REST responses for people who weren't even using the data. So now as a backend developer, you don't have to deal with that. And it was also really easy for people to start moving to microservices once they had a GraphQL API because there's this nice abstraction layer on top that means you can switch out the backend however you like. And so, okay, as a server-side API technology, really cool for backend developers. Personally, I'm a front-end developer, so what do I get out of all this? Well, so the biggest thing you get if you have a GraphQL API is you get to develop your UI much faster. And there's just so many different ways in which you get to do that that we'll go over here. But basically, at first glance it might seem like GraphQL is maybe a more complicated way to get your data than a REST API, because with REST you say, well, I want this object, fetch the object, please, and then you get an object. And with GraphQL you have to type a little bit more, you have to type the fields. It might sound like a little bit more work, but I think actually it's probably a lot less work to build your UI once you have GraphQL. So to start with, let's start from the total basics. How do you even get data out of a GraphQL API? It turns out you don't need any fancy tools at all. You can query it exactly the same way you query any HTTP or REST API before. I don't know if you're JavaScript developers, you probably know about fetch. It's kind of a new standard for getting data from servers. You might have used jQuery before or something like that. But the same way that you can just fetch a URL to get your REST resource, you can fetch a URL to get a GraphQL resource. You just call the GraphQL endpoint, you pass the query right there in the URL, and you're done. So you can call a GraphQL API with curl, you can call it with Python, with Ruby, with Go, with Java, literally anything you want. So there's no downgrade here. You don't need any special tools that you didn't need before. It's just better. And so how is this better, even if we don't introduce any special tools? So for one, we already know exactly what fields we're going to get. So we don't have anything unexpected coming from our API. Either the request is going to fail, in which case that field doesn't exist, or you're going to get exactly the field that you wanted. Another thing that you get that's really great out of the box is built-in documentation and data exploration. Something that you used to only get when you're using backend as a service. Like when you're using Firebase, people often raved about how great it was to be able to just explore your data directly in the UI without having to run any database queries. With GraphQL, you get that in your own backend. You no longer have to use a backend as a service to get some of those fancy features and fancy stuff that you were expecting. And like we mentioned before, it's easy to get nested data. And this is all without introducing any additional tools. You use curl, you use fetch, you pass a GraphQL query, and you're good to go. Okay, so that's with no tools. What can we do if we introduce just a small amount of tools? And I'm going to talk about basic tools because these are simply tools that realize that a GraphQL query isn't just a string. The GraphQL query is actually a structured object, you could think about it, with fields, arguments, nested selections, all that stuff. It turns out it's actually really easy to access that structure and leverage it to build better tools than what we had for REST APIs without having to build any of the extra work that you would have to do to get that with REST API. So for example, well, I guess to start with, it's like how do we build the tool that finds our GraphQL queries and does stuff with them? And so it's very easy. If you're using JavaScript, for example, you could just take your multi-line GraphQL string, and you could just annotate it with a template literal, which is a new feature in ECMAScript. So a lot of GraphQL clients you'll see have a little thing in front of the query string, and what that does is it lets build tools know that this particular string is a GraphQL query. So you might have other strings in your app. You don't want tools to target those. You only want them to target the GraphQL query strings. And then you could imagine running a really simple regular expression or AST traversal or something on your code. you'll be able to really easily pull out all of the GraphQL queries from your code and analyze them separately. So they're no longer just magic strings in your code, which is something like, it might feel like that way when you first get started with GraphQL because, as developers we've been trained to hate typing large strings in our code because, why not use code? But it turns out with GraphQL, it's actually much better to type your GraphQL queries as strings in your code because then you can use all of the great GraphQL tools that we're going to talk about to analyze those strings and do great stuff with them. Another alternative that actually Facebook does in their native mobile apps is they put their queries entirely in separate files, in files with the .GraphQL extension. And they compile them in fancy ways that we'll also talk about. So now that we have this query and we're able to pull it out of our code, what can we do with that? Well, so step one, really easy stuff. We can analyze all the queries in our UI statically. So we can write a tool that goes through all of our code, finds all the GraphQL queries, and checks them against our backend. So maybe you made a typo in a field name. Maybe you put in the wrong type of argument. Maybe you're using a fragment that doesn't exist or something like that. And there's a tool today you can use that actually we put together that's just an ESLint plugin that you run against your code. You tell it how to find your GraphQL strings, and it will, if you're using an editor with ESLint integration, it will literally underline the exact field in your API request that is incorrect. So that's one thing you can only do if you have a technology like GraphQL with a static description of the backend and a static language for defining your data requirements. The next thing you can do, which I'm super excited about, is people have started actually building way fancier integrations. So there's actually a package you can get for IntelliJ that will give you all the functionality of GraphQL, and GraphQL is that query explorer that we just talked about, directly inside your IDE. So you start writing your UI code, you type an open bracket for a query for data you want to fetch, and it tells you exactly what fields you can get there. And not everyone might be into static typing in JavaScript land, for example. But I think the farther away the thing you're accessing is, the more valuable it becomes, because that GraphQL schema probably doesn't even live in the same code base. It might not even be the same team that wrote it. But now, as you're typing your UI code, you can get that data right away when you need it. And there's a lot of other fancy features that this IntelliJ plugin has, so you guys should definitely check it out. And the Facebook team that built GraphQL is actually also working on a generic GraphQL language service. So you can build the same integration for Atom, for Sublime Text, for any other editor you're using. You can hook into this auto-completing functionality and get it basically for free just because you have these wonderful query strings to work with. And the best part is, you don't have to be limited to just the tools that are out there. It's super easy with the technology that exists today to build new tools. So for example, there's GraphQL.js, which is GraphQL's reference implementation. And while it also includes a way to build your own GraphQL server, Facebook internally actually uses it entirely for developer tools. It includes a bunch of utilities for parsing, validating, transforming GraphQL queries that you can use to build your own stuff. The GraphQL AST is also super easy to work with. There's a great website called astexplorer.net. So if you want to look at a GraphQL query and look what the parsed version looks like, you can just go to this website and type in a query and see exactly what fields are in there and how you might manipulate them with code. And like we mentioned before, every GraphQL server, to be spec compliant, is required to provide information about what data is available. So if you put all this stuff together, you can build basically any API tool you could imagine on top of GraphQL. And that's just with technology that's coming off the shelf today. All right, so now to the part that I spend most of my time working on, which is, all right, so we went over how you can fetch a query with just a string through fetch. We went over what you can do if you have static build tools that can look at that query. What can you do if you actually take advantage of the query shape at runtime? So basically, you parse the query ahead of time, and then on the client, when you're loading that data, you have that query right there, and you can take advantage of its shape to do smart things. So yeah, I mean, on the slide, two examples of these smart caching GraphQL clients are Relay, which is the one that was built by Facebook and released at the same time as GraphQL was, and Apollo, which is the one that we work on. And I can get more into the differences later if you guys want to talk to me, but that's not the focus of the talk. So to start with, let's just think about how we might cache a REST API, just in a naive way. Well, one way would be to use the URL of the REST endpoint. And we might get pretty far because URLs map pretty well onto just the individual objects that are returned. If our API is a little bit more complicated, we might want to use Redux or something like that, and we want to take our response and actually decompose it into separate objects so that on the client we can have a store that actually represents the set of objects that we fetched, even if our fetch is nested. So there's definitely a couple of strategies with REST that you can use to cache. The problem is that a lot of these tools are going to be pretty specific to your particular REST API, because there's not really a good standard for how you're supposed to structure the return data. So an organization like Coursera that has a lot of developers, you guys can build all the tools that are specific to your APIs, but if you're just a small company, for example, you might not be super in luck about that. So what can we do with GraphQL? Is it easier or harder to cache GraphQL replies? Well, okay, we could fall back to the same thing we had before. We could just use their URL, and we can pass the query in the URL, and we can put the query result into our cache. And that's cool. If we do the same query exactly again, then we'll get the same result. That's pretty nice, not too bad. But because we have this fancy query structure, we have a lot more potential for actually identifying what's in that response and building an automatic caching layer for it. For example, just as a human, look at these two queries, right? First, we have a big query that gets the post and the author and some fields. And then let's say later on in our UI, we make a smaller query that has the post and also some of the fields that we already had. These queries are not identical, so if we used that URL caching mechanism, we probably wouldn't get too many results out of it. But you can see that we can just statically determine these two overlap. And so the very first thing that I think a smart caching GraphQL client should be able to do is identify that the second query is a subset of the data we already fetched and give that result to you immediately if that's what you like. So one way to formalize that concept a little bit more clearly is you can think of a GraphQL query as a set of paths. So at the end of the day, all this stuff is just structure until you get to the leaf of the query, the fields that are actually returning data. And so if you just write that down as a set of paths that you're getting, so post ID 1, then you get the title, and then post ID 1, you get the content. You can very easily identify where these paths are overlapping between the two queries. And so if you cache your data in a format that looks like this, you can get a lot of more caching for free than you would be able to do with something that doesn't have a structured API language like that. So that's something that Apollo client, I think also Relay, will do for you out of the box with no additional effort. As soon as you start fetching GraphQL queries through one of those clients, you're going to be able to identify subsets of data you already have and decide whether you want to fetch a new version or if you want to use the one you already have. Okay, but it's also not ideal because in addition to avoiding loading new data, that's one purpose of a cache. Another purpose could be to have your UI be consistent. So you can imagine in your sidebar, you might have a list of posts. Let's say it's like some weird blog with a sidebar. And then you might have a main view that displays that post. And what if in between fetching that sidebar and fetching that main view, the result actually changed on the server? Somebody updated the title of their post. It would be pretty confusing if your sidebar showed one title and the main view showed a different title. So this gets at the idea of cache consistency, which is that we want to make sure that whenever we have some piece of data in our UI, it's being stored in the same place in our cache, so that you don't end up in a situation where two parts of the UI that should be the same actually end up different. And so that's why in addition to the paths, because even though the paths and the queries here are different, we need one more concept. Okay, this is visualizing the paths again. We need one more concept, which is we could use a caching ID that we can generate based on our results. So, for example, if we were able to reconstruct the paths to be like this, because we know the first item in the post feed has ID 1, and we know that the result of that query also has post ID 1, we should be able to point those to the same place in our cache, so that when we access the title, we're looking at just one field, and it has the new value because that got overwritten by the new query that we fetched for the same data. And so, okay, yeah, so this is like the two things that you can do using GraphQL's inherent structure, just based on the spec, to make caching data and making your UI consistent really easy. Also things that both Relay and Apollo will do for you. All right, so let's say we have this cache now. You guys might be familiar with other caching strategies like Redux or Flux is definitely the biggest one, React-Land, there's other stuff in other frameworks that people use. But how do we actually operate on this cache to make it do what we want, beyond just loading queries and replacing the old results with new results? So we can actually play with the data flow of our app a lot, but let's start with the basics. The basic idea is, this little cylinder represents our cache on the client. Basic idea is we want our UI, represented here by the React logo, to be rendered directly from our cache. And so the query is a representation of the data from the cache that we want. Just like we use the query to load the data from the server, in this flow, we also use the query to load the data from the cache. And that way, If the cache changes because we got a new result or we updated it in some way, our UI is re-rendered again to be consistent with the state of the cache that we have on the client. And another really great thing about GraphQL that we can see here is GraphQL is equally good as a language to load data from the server, but also to load data from a client-side cache that represents that server-side data. We no longer need like two different languages, one to actually get the data to the client, and the other one to load it from there. Whereas in a REST API, right, one language might be the REST endpoint URLs, and the other language would be maybe JavaScript functions like you would use in Redux to select data from your store. But here we can use the same language, letting us just annotate our UI component with a query and have that do both steps, both fetching the data and putting it in our UI. Okay, so what else can we put in the cache? Well, it turns out we can put basically anything we want in that cache as long as we have the tools to do so. So GraphQL has mutation results, for example. You might update the data on the server, refetch some data. You want that to end up with your cache so that your UI updates. You might do other queries that refetch data that might be stale, so you want that to update it. You might have GraphQL subscriptions, which are a new feature in GraphQL that people are working on to get real-time data updates. You want those to update your UI. And one thing that we've been playing around with and are really excited about is basically letting you update your GraphQL cache from literally any event that you like. Right? You have a source of WebSocket updates, put that in the cache. You have some Redux actions, put it in the cache. You have anything you want, the only thing you have to do is annotate your UI with a GraphQL query, put the right data in the cache in the right place, and your UI updates magically and remains consistent. The way that we're starting to think about this is it's kind of like an automated Flux architecture, where it's like a Flux that's actually aware of the structure of the data you have on your server, rather than having something that lives entirely client-side, where it's your job to format the data in the way that you like. So that's pretty much all I had for an in-depth dive into that particular set of tools. So I hope that got you guys already pretty excited about the potential of stuff you can do with GraphQL and even tools that you can build yourself. And we're thinking of a lot of more stuff for the future, and the GraphQL community is building a lot more stuff coming up really soon. So one thing we actually published this morning is a blog post about static code generation for iOS. So for REST APIs, people will often use these code generators that will give you typed results so that you can auto-complete that data in your UI code so that you can make sure that you're fetching what you want. And with GraphQL, because of the structure of the query and schema on the server, again, we can do that automatically, so you can check that out. There's also GraphQL subscriptions, which, like I said, are a pretty new thing. And we didn't go over how that real-time aspect works, because most of GraphQL is just a request-response model. But you guys can definitely check that out and ask me about it later, how that works. And later, the things that we're really excited about that people are also building is the ability to fetch client-side data with GraphQL. So you guys might have heard about that from the Relay 2 announcement. That's something that Apollo is also doing because we want to be able to put basically any data you want in that cache or fetch it with GraphQL. For example, your client-side geolocation data, or maybe you have some temporary form data associated with a GraphQL object, but not actually living on the server. Cache expiration would be really cool, so that instead of just deciding whether you want new data or you want old data, you would know exactly how old that data is, so that you can make more intelligent decisions about when you should use the data from the cache and when you need to refetch it, which is something that could be built via some conventions on top of GraphQL, or maybe in addition to the spec eventually. And the other thing I'm really, really excited about that we're also working on is letting you build your own customized GraphQL clients, right? So one thing we're really acutely aware of is no one GraphQL client solution can work for every single app, right? One of the main benefits of something like Redux or all these other client-side data things is they let you do basically anything that you need to do to get your app to do what you want. And so, the particular caching model that Relay or Apollo has might not be a great fit for your application, especially if you want to mediate between two different client-side stores, for example, if you're trying to incrementally adopt this technology. But we're really excited to be building some technology that we're releasing that will let you basically build your own GraphQL client by extracting all the stuff that we talked about before, about analyzing the data you already have and what you don't have and having these cache IDs so that you can build what you need for your own organization. Anyway, and if this is exciting for you guys, please come talk to me and let's work together to get it done. So, thank you. Cool. Does anybody have any questions?
Yeah, is there any common defaults or common mistakes that people run into when they interpret their existing REST API?
Yeah, the question is, do people have any common mistakes that they run into when they integrate their existing REST API with GraphQL? I think it's pretty early to tell. A lot of the people who've been using GraphQL so far are people who are like see the potential of the technology and are really excited about it, and they're like, like you guys are sufficiently motivated to get those benefits, and so you know what benefits you're looking for. So a lot of the stuff I've seen has made a lot of sense for that particular organization. I would say my biggest pet peeve, and I don't know if it's like too opinionated or something, but like when people start writing their GraphQL queries not using the query language, but using a query builder or like a JSON blob, because then you're no longer able to do the static analysis that you would be able to do if you use the query strings. So people think, yeah, GraphQL is a great way to fetch data, but I don't like the query language. I think the query language is one of the best parts, and it's one of the things that makes it so easy to type a query in graphical and then paste it into your UI code and be going right there, or use one of those auto-completing IDE tools. So that's one of the biggest things. I think just people who don't yet understand the value of having a static query language to fetch their data with, I think people will start understanding that soon. Any other questions?
I'm just curious how this in general environment work is like, especially when you are making queries, like some like part of the query may fail, but how to handle it.
Yeah, so the question is, how does error handling work? Because you might be doing quite large queries and some subset of the fields might fail, but maybe not the whole query. That's definitely a thing that is not as solved as it could be in GraphQL. So in general, how errors are returned, I don't really have a good example to show, but in general, how errors are returned is usually the field that had an error is returned as a null value. And there's a separate part of the response other than data that lists the errors that happened during execution. My biggest concern at the moment is it's not always easy to match up the error that you get in the errors field with the field that is missing from the response. So one of the things that we're pushing for example, is to make it so that the errors have a path in them, so you can know, okay, this field is null specifically because of this error, and use that, for example, in your UI. Because when you're using REST APIs, you get a separate error for every API endpoint you call. But with GraphQL, because you might be fetching from many, many endpoints at once, we definitely need better tools to figure out where those errors came from. And that's definitely one of the points where it could be improved. Although there is a mechanism today, but like even I think when I talk to people at Facebook, they're like, yeah, we don't, they have some measure internally of like error severity, where they're like, okay, if an error is like really severe, we throw away the whole query result and we don't show anything. If an error is like only a little bit severe, we just like forget that it happened and then just like put the data in there anyway. So yeah, that's definitely something you could use improvement. Yeah.
So Yahoo has something similar in YQL, and one of the issues was multi-source data queries were not very performant. Can you speak to any of the server-side performance optimizations in GraphQL?
Yeah, so the question is, if you have Yahoo had a previous language like this that may have had some issues on the server when you fetch data from a lot of data sources, how do you make that performant? That's a thing that also is not super solid in GraphQL right now, in the sense that I think the way it works internally at Facebook, whose backend is quite different from what a lot of other people's backends might look like, they have a really efficient way to fetch individual objects from their cache or their backend, and so I think each field basically represents an object that they're fetching, so they don't have that problem. In the wild, in open source GraphQL land, there are a couple of strategies. I mean, the first question to ask is really like, is this the biggest blocker for performance? Because one thing you can do, for example, is make sure that if you're fetching the same resource over and over again, to have a really like simple per request cache in your server, so that like, if you have a list of posts and each of those posts has an author and it's like the same author for every post, to make sure that that query only fetches the author from the backend once instead of like 10 times. So that's a really simple thing you can do in addition to batching requests for multiple objects together. So that's something that everyone's doing in the GraphQL community, I think. Some next level stuff might be building tools to analyze the structure of the query ahead of time. So for example, you might want to, if you're using SQL, you might want to only select the rows that you're actually asking for in your query versus just fetching like the entire row with all the fields. And that's something people are working on, but I think it really starts to depend on your particular backend. But like, in theory, it seems like it should be able to be more efficient because in a lot of other kinds of APIs, you don't even know what fields people need, but here, at least it's theoretically possible to figure out what fields people need ahead of time and optimize your query for that, but I don't think there's a lot of off-the-shelf tools that will do that for you right now. Cool, anything else? Okay.
I'm curious, like when GraphQL is executing mutations, like there's some in process currently that we have to catch it from like show some loading icon or something. How does this generally work?
I guess, correct me if I'm wrong, the question is how do you show a loading state while a mutation is executing? I think you do it pretty much the same way that you would do it for I think you would often do it the same way you would do it for a post request in REST or something like that. When you fire the request, because the mutation is just another HTTP request that you send to your server. So I guess when you start sending the request, you would initiate showing a loading indicator. And then when the request returns, then you would stop. So one property that mutations have in GraphQL, which is not obvious, is mutations can also be the root of a new query, essentially. So in the same request, you make the modification of the backend data, and then also refetch the stuff that might have changed. So by the time the mutation request is done, hopefully you have all the data needed to represent the result of that mutation in your UI. Rather than other systems, for example, where you might need to make the mutation and then refetch, or make a mutation and then perhaps wait for an event to come in over some other channel. So GraphQL has a facility for making a change and refetching in one request. I hope that answers. Okay. Anything else? Yeah, if you guys have any specific questions about the stuff that I was talking about, or any want to work together or anything, just, I'll be around after this, so just let me know. Cool. Thanks a lot, guys.